All right, hello, Remington and Kaylin. This is 2-1. We're starting chapter 2, writing and interpreting equations. And I think for the most part, the equations that we do are going to be linear functions. Do you know what a linear function is?
Something equals something.
Kind of.
Like x you can plot it on a graph.
So a linear function, if it's a linear function, it's going to be a line, right? If you graph it, but we're not graphing them yet, okay? And it's going to be some form of x to the first power. Oh, I need to plug in. Some form of x to the first power, right? So for the most part, what? If it has an equal sign, it'll be like y equals x, right? Okay, that's a linear function. Or maybe it's y equals 2x minus 3. I don't know. That's a linear function, okay?
That's your negative 3 star.
Right. Yeah, exactly. Yeah. We'll be doing that. And so, like, let's say we have y equals x squared plus 7x minus 3. I don't know. That is not a linear function. This is a quadratic function, is what it's called, which you'll learn maybe in this chapter, in this class. I don't know. Mostly in algebra 2. But this is a quadratic function because the highest power is the second power. Okay. In a linear function, your powers are all going to be to the first power. Got it? Okay, so I think that's what we're doing here. It says try writing an equation for the sentence 20 minus the quotient of 7 and x. Okay, 20 minus the quotient of 7 and x. Let's stop there. Okay, stop where the word is, right? Circle the word is. Is means equals. Is means equals. Okay, so let's just go in order. 20 minus. What's the quotient of 7 and x? What's quotient mean? Divide. So I'm dividing 7 and x. Which one goes on the top? 7, because it was listed first, right? The quotient of 7 and x. So 20 minus 7 and x is equals twice x. What's twice x mean? 2x. That's what this equation looks like. 20 minus 7 over x equals 2x. Okay? Good? They don't want us to solve it at all. They're just having us write equations. Okay? Good? All right, example 2. Of the 799 teens surveyed about what they do online, some use a social network. Of those on social network, 430 say that people their age are mostly kind online. Okay? So they surveyed these people, said, do you use a social network like Snapchat or whatever, right? And are people nice to you or are people not nice to you? Are people nice on social media always? No. Isn't that just a thing? No, they're not, right? We know that. That's a thing, okay? 193 do not say that people are nice, right? Okay? So that's more people that say that they're nice versus not nice, right? Write an equation to find the number of teens surveyed who are not on social network. Okay? So, 799 teens is what we started with, right? 799. Okay? Those are kind of split in half. Some say yes, people are are nice. Some people say no, they're not nice. How many people said yes, they are nice? 430. How many people said no, they are not nice? 193. Does that add up to be 799? No. What does that add up to be? 623. So then, how many people are left? 176. And what happens to those 176 people? They are not online. They're not on social. They're online, but they're not on social media, right? Okay, so maybe they're online just looking up stuff for a book report or whatever, right? Okay, but they say write an equation to find that, right? So what kind of equation do we do? 430 plus 193, got it, okay.
And then it has to be 190 minus.
I'm going to say plus x equals 799. And we just solved for what x was. What was x?
175.
176. Okay, so this is the equation that they want, I think. Let's see. Do they give us an answer? No, they don't. Okay, but that's going to be the equation that we're going to do, right? Those 3 parts added together. These people are
99 minus 430 plus 196. Is that correct too?
Okay. So Lane just says if we do this, x is equal to 799 minus 430 plus 193. As long as you put them in parentheses. Yes, that works too.
Right, but that's just the second step.
That's fine. It doesn't matter. Yeah, that works. That's like what you do to solve for x. Yeah, that would work too. I would accept that as an answer. There might be multiple answers. Also, another way of writing this is 799 minus 430 minus 193, right? Because in other words, you remember we did this last chapter, we distributed the negative through, right? Negative, negative, right? If we want to drop the parentheses, we distribute that negative through, so that's another way of writing what x could be, right? Okay, so any of those three would work. Those are all equations for solving what we're trying to find, okay? Good, good? Does that make sense?
Yep.
Yeah? Okay, let's go to example 3. Actually, let's go to the check, maybe. I don't know, how many examples do we have?
Like 6.
Nope, let's go to example 3.
Yay.
Write an equation with multiple variables. Okay, so we're going to have like maybe an x and a y. Or sometimes people will use it as like perimeter. We call it P maybe, right? Okay, length, width, all the things, right? Okay, so perimeter of a rectangle. There's that word is. Circle the word is. Perimeter of a rectangle is. Okay, so let's do that much. What should we write down for perimeter is?
P equals.
P equals, perimeter equals, okay? Twice the sum. Twice, and then we're going to have a sum after that. So I'm going to put that in parentheses because we want the sum to be done first, right? 2 times the sum, which is going to be a group, right? Twice the sum of the length and the width. We're summing the length and the width. What should that look like?
L plus W. Or
L plus W.
L.
Yep. Length plus W. This is the sum of length plus W. Twice that is equal to P. Yeah? That is truly what the perimeter of a rectangle is. Right? You know that? A rectangle. This is length. This is width. Right? Okay? If I do that, there are 2 lengths and 2 widths. So basically, if I add these two together and double it, it will give me all 4 sides of the perimeter. Right? Okay? Okay? So that's another way of writing that. And that's all they want us to do. They don't actually want us to solve anything, right? That's example 3. Okay, interpreting equations. Sometimes we have what's called a constraint, okay? And a constraint is a condition that a solution must satisfy, okay? So, these conditions limit the number of possible solutions. The solution of an equation meets the constraint of the problem. So, if I go back up to this one, and I'm talking constraints, right? L and W are going to be the numbers that we plug in. They're going to be the input variables, right? Like X is usually the input variable. P is the output variable, right? What numbers can we and can we not plug in for L and W? We could plug in like an irrational number. We could do like the square root of 2 is maybe a side length. We could do that. We could do an irrational number. What?
We could, if we put
Something
in a
what?
negative. Less than the output.
But we don't know what the output is.
What if we put in a negative?
Oh, can we put in a negative?
No.
No, we can't put in negatives. So that would be like a constraint, right? You cannot have negative numbers in for L and W. Got it? Okay. So constraints like that, like what can it be, what can it not be? P will end up being
Positive.
a positive number, right? We know that because L and W are going to be positive numbers as well, right? Okay. So there is constraints. Okay, let's go to example 4. I'm making this person dizzy, whoever's watching this. Write a sentence for the equation. All right. We know that equals just means is. This is what we're used to doing in chapter 1. How should we represent 2z?
Twice X.
Twice.
Z. 2 times a number.
2 times a number. Twice a number. I'm paraphrasing.
Minus 1
Minus 1
is 5.
is equal to 5 or is 5. That works. How about the product of 2 and a number? You don't have to write this down. The product of 2 and a number. Minus 1
What about
is
twice
5. Twice z will work.
Z? Number is 2.
Twice z
Or the
minus.
product of 2
Ooh.
and Z? No.
Yep, minus 1 is 5. Any of those will work. Okay, any of those will work, right? Any of those will work. Good, good? Okay, similar to what we were doing in the last chapter. It's just now you have an equal sign. Okay, write a sentence for the equation. All right, here we go. We've got 3 times y plus 1. Okay, so I'm gonna say 3 times.
3 times the
Okay,
sum of
but
y.
I want to make sure that we know that this guy is in parentheses. So that's all going to be grouped together. So 3 times
The sum of.
or you can do the quantity of y plus 1. If we just say the sum of, we don't have to say y plus 1. We could just say the sum of y and 1
Is 12.
is 12. Okay? Good? 3 times the quantity of y plus 1 is 12. That would work too. Any of those? Okay. Just make sure that you know when it's in parentheses, you want to use that wording, like the sum of or the quantity of. Any of those. Okay? That was example 5. Grouping symbols. All right. Example 6. They're giving us a formula for this. Holy moly. Write a sentence for the formula for surface area of a rectangular prism. Oh. All right. This is how you find the surface area of a rectangular prism. We do that in geometry, like 2 years from now. Okay. So it's these 3 parts put together, added together, give you the surface area. Okay. Good, good. Kind of a mess. All right. They want us to write a big long equation for that, or like write out the words. Okay. So surface area equals. They gave us this part right here. 2 times the length
So this would be 2
times the height
times
plus, they said 2 times the length times the height.
2 times the length plus times the width plus the height.
If we do the same thing that they did here, we could do 2 times the length times the width plus this piece, right? I'm just doing kind of the same format as they did in the second one. So 2 times the length times the width plus.
L length times width times 2, or like reword it so that
Sure.
it's less.
Twice.
Yeah,
L
you might be able to.
times
Yeah,
W.
I just chose this wording because they did it in this wording. So I'm doing in a kind of similar wording.
Twice,
Okay.
Would twice W
Plus.
L times W work?
Yeah. Sure, that would work. Yeah. I'm going to do the same wording here. So 2 times the width times the height. So that whole big long equation, if you word it, it says the surface area is equal to 2 times the length times the width plus 2 times the length times the height plus 2 times the width times the height. Yeah? Like that's how you would say it out loud if you were to write that equation. I probably would say 2LW plus 2LH, right? And the fact that they're together implies that they are multiplication, but technically that means times all the way through. Does that make sense? Okay. So if you were to properly say this out loud, it would be 2 times L times W, or 2 times length times width, whatever. Okay. That was a lot because there was like technically four parts to that. Woo! Okay, what else we got? Was that it?
Yeah.
Oh man, we're not even solving for anything. We're just writing out the wording. Woo! Love it. Love it. Okay. Let's do boop, 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 boop.
Evens all into fours.
Evens to 34.
No,
Evens
I
to
saw
14.
What?
Evens to 14.
Evens until
Evens to
1.
4.
30. Evens to 1. Let's
One
go
isn't
1
even
through 4 by 4.
We'll do 0.
Let's do 1 through 4 by 4.
I would
1 through
agree with
4
that
by
one, Miss
4.
Governor.
What?
1 through 4 by 4.
How about we go
I don't
through
think so.
all of them, but go by 61s? By 60.
Ha. 2 through 10 evens. Whoop. And then 12 through 32 fours.
What? 12 through
2 through 10 evens, 12 through 32 fours.
Why you gotta make it so confusing?
I'm sorry. I'm trying to cut it down. I was going to do 2 through 34 evens. Yep. So 2 and 4 and 6 and 24, 28, 32.
4, 5, 6, 7, 8, 9, 10, 11.
11 problems? That's not bad.
I might fail.
Okay? Good?
Preston, you can fail even if there's one problem.
Alright.
Alright.
Yeah.
That's just
Yeah.
And just
Person, I could fail with 0 problems.
All right, there you go. Goodbye. Who is watching this? Kaylin and
Remington.
Remington. Goodbye.